Okay, let's talk about the brine system and dilution water. In order to regenerate our softener beads, we pump in brine along with dilution water to reach the proper salinity for regeneration. This pump and valves will be shown on each skid detail also. Now let's go to the detail for skid 1. Here we see normal operation. You can see permeate comes in through here, through the permeate inlet valve, flows through the softener. When it comes out the softener, it passes 2 inline conductivity probes with flow switches. We go out the discharge valve and on to the deaerator. High conductivity or no flow will cause a permeate divert, which will interlock this valve open and interlock this valve closed, which will divert water to the waste tank. Certain criteria have to be met before we can regenerate. If we want to regenerate this skid, we have to take it offline. This manual valve must be closed. Our permeate pump must be on to provide us with dilution water. We can't have any alarms, and the brine tank level must be okay. This is a manual valve, and it does not have feedback. Now I'm going to take the skid offline. At this point, all the valves close and go into operator mode. Water from the permeate pump will be divided between the other 2 skids. Here we see the cycles of the regeneration process. These will be set in minutes. Right now they are in seconds, so we can go through them. I will start the regeneration. First, we enter the backwash. It opens the backwash valve. You can see the arrows change direction, indicating flow to the waste tank. Backwashing is to get any sediment or particulate out of the softener. It will do this for a predetermined period of time, and then it will go into settle mode, where it isolates everything and lets it settle. After the settle, we enter the brine draw, where it will open up the brine inlet valve, the dilution valve, the discharge valve for the brine pump, and it will start the brine pump. The brine pump is on a variable speed drive. We vary the speed of the pump to achieve a gallon per minute set point. Next is the brine soak. After the soak, we are going to start a slow rinse. The dilution valve opens, the brine inlet valve opens, and the brine rinse outlet valve opens. This is a slow gallon per minute rinse. After this slow rinse comes the fast rinse, where the skid is basically online, but the water is being diverted to the waste tank instead of being sent to the deaerator. After the fast rinse, you will see complete confirmation required in the status box. If this valve is open too long, you will get an alarm to let you know that you are still sending water to the waste tank. At this point, there are 2 things you have to do in order to get back online. The operator has to take a manual sample and open the manual valve. If the sample is good, he can check here saying that he has verified for proper conductivity. These 2 probes cannot be an alarm or the skid will not go back online. If our conductivity is good, we can open our manual valve. We can confirm that we checked conductivity and we have proper conductivity. And we can put our skid back online. The operator must put it back online. This does not happen automatically. You have some options during a regeneration. You can cancel, hold a step, isolate a step. You can cancel only in settle or fast rinse. If you have started a brine draw, it must complete both flushes. You cannot cancel. A step hold will freeze the timer on that step. So if you want to extend a cycle, such as a brine soak, you select step hold while it's in the step you wish to extend. This will hold the step till you take the step hold off. To use this, you must be in regeneration mode, and isolate must be off. A step isolate will freeze the timer and also isolate the skid by shutting all valves. You must be in regen mode to use step isolate. Our softeners have a critical 1 and critical 2 alarms similar to our RO skids. A critical number 1 alarm will take the skid offline, isolate it, and put the devices in operator mode. I'm going to go to our first outs. If you'll notice, we have the same valve failures under critical 1 and critical 2. What defines a 1 or 2 is when the valve fails. If it happens during a regeneration, it's a critical 1. If it happens during normal operation, it's a critical 2. Critical alarm number 2 will also take it offline, but it does not step isolate because we are not in regeneration. Thank you.